pkt plus del t equals to pk minus 1 t lambda k minus 1 del t plus pk plus 1 t mu k plus 1 del t minus lambda k plus mu k pkt del t. So now the expression we get pkt plus del t equals to this. Now there are some arrangements, or we can change the places of some terms. So pkt plus del t minus pkt upon delta t equals to here another term is pkt. So this term comes here, this side to this side, upon del t is common in each term, so it comes upon, so equals to pk minus 1 t lambda k minus 1 plus pk plus 1 t mu k plus 1 minus lambda k plus mu k pk t. So if the limit del t tends to 0, then we get, now we applying limit. So if limit del t tends to 0, then dpkt upon dt equals to pk minus 1 t lambda k minus 1 plus pk plus 1 t mu k plus 1 minus lambda k plus mu k pk t. This is our expression. dpkt upon dt equals to pk minus 1 t lambda k minus 1 plus pk plus 1 t mu k plus 1 minus this. So this our first expression for dynamics, for governing the dynamics of a birth death process. So this is our main expression. This particular equation satisfied only for whenever the value of k is always be greater than equal to 1. So this particular equation only satisfied for these conditions. If k equals to 0, if k equals to 0, then if k equals to 0, if we put k equals to 0 in this equation, then here the value is p0 minus 1 t lambda 0 minus 1. So it means there is a state have the value minus 1, which can't be possible. No state or no population mentioned in terms of minus 1. First thing. And second thing is that whenever k equals to 0, the mu naught equals to, whenever k equals to 0, it means if k equals to 0, first thing is that there can be no state with minus 1, and the second thing is there can be no termination of call. So mu naught equals to 0. Mu naught equals to 0. If mu naught equals to here, if k equals to 0, then it means it is if k equals to 0, there are two things. First thing is that here p0 minus 1t, it means there is a minus 1 state, which can't be possible. And second thing is that there is the value is mu 0. It means the state where no population. If there is a state there is no population, then there how can be a death occur? So it also equals to 0. So mu naught equals to 0, and this state can't be possible. So now the expression for at k equals to 0, dp naught t upon dt equals to p1 t mu 1 minus lambda naught p naught t. This is the particular expression when it is second equation and it is numbered as 1 and this one numbered as 2. This expression for k equals to 0. So we have two particular equations. First for k is greater than equal to 1, and then second one is k equals to 0. Both are the particular BD process equations. Now further we will discuss about the BD process under steady state condition. Now we will discuss about the birth death process when it goes under steady state condition. Under steady state condition. For steady state, first thing we have to understand here, what is the steady state condition. The state probabilities reach an equilibrium value and do not change with time. Whenever the particular state probabilities do not change with time, it means remains the same. So this particular state, when the particular our state reach an equilibrium value, then this condition is known as steady state condition. So at under steady state condition, the state probabilities reach an equilibrium value and do not change with time. So pk t1 equals to pk t2 equals to pk t3 equals to, we can write down p base k. It is independent of time, yani that means it doesn't change with time. So we have dpkt upon dt equals to 0. It means the rate of change with time equals to 0. So dpkt upon dt equals to 0. So now this particular term, both the terms can put in the particular starting two particular equations. So now the new particular expressions for the BD process becomes stationary. Therefore, the steady state equation of BD process are. So first expression pk minus 1 lambda k minus 1 plus pk plus 1 mu k plus 1 minus lambda k plus mu k pk equals to 0. This is the expression for k is greater than equal to 1. This is our expression 3. And similarly p1 mu1 minus lambda naught p naught equals to 0 for k equals to 0. It is our equation 4. So for these the both equations for under steady state condition. So for under steady state condition, the particular rate of change of probabilities with that means with time equals to 0. So dpkt upon dt equals to 0. We put these values in equation 1 and 2. Now we will get two expression this. So both the expressions are the BD process becomes stationary, therefore the steady equation of BD process under steady state condition. So till now we will discuss about the random processes, the modeling of a switching system. Now we model the particular switching system telecommunication network under birth as a birth death process. Now there are some special cases of these birth death processes. So there are two special cases of birth death processes. Then first one is case 1, which is known as renewal process or pure birth process. And case 2 is pure death process. So here we are discussing about there are some special cases of birth death process. Case 1, which is known as renewal process or pure birth process, and case 2, which is pure death process. So generally both the cases defined by its name itself, pure birth and pure death process. So now we will go for the first case, which is case first, which is pure birth process. This process can be treated as a special case of birth death process in which the death rate, it means mu, always be equals to 0. So it means there is no death occurring in the process. Such a process is known as renewal or pure birth process. It means in the first case, or we can say that in this special case, the birth death process, the death rate is equals to 0. So death rate is equals to 0. So there is no chances of death. It means in this case only birth occur. So that why it is known as pure birth process, or we can say that a renewal process. So it can only add to the population as time goes by for pure birth death process. So for finding the particular dynamics of this pure birth death process, or we can say that to finding the expression for pure birth death process, so put mu k equals to 0 in equation 1 and 2. So pure birth process means there is no death occurs. So that's why death rate equals to 0 and only birth occurs. So it means a pure birth process or renewal process. For this we can put mu k equals to 0 in equation 1 and equation 2. After putting the value in equation 1 and 2, now we have the particular value of this particular pure birth process is like this. The first expression is d p